Hello, everyone. Welcome to our webinar, How Engineering Teams Overcome Product Data Management Problems, presented by Cadalyst and sponsored by Onshape, a PTC business. This is Serena Respini-Irwin from Cadalyst, and I'll be the moderator for today's session. In this webinar, you'll learn about the role that data management plays throughout the product design and manufacturing process, and about the differences between file-based and cloud-based data management systems. You will also see how distributed teams can use a cloud-native product development tool to access a single source of truth for their design data. The presentation will be recorded and made available to all registrants. You'll be notified via email when that recording becomes available. The main presentation today will be followed by a Q&A session. At any time, starting now, you can submit your questions via the Q&A tab in your big marker chat panel. If you don't see the chat panel, please click the blue chat button at the bottom of your window to bring it up. And in that same panel, just to the right of Q&A, you'll see a tab marked Polls. Please click on that to answer a poll question about how you currently store your engineering data. Now it's my pleasure to introduce Dan Kane, Senior Technical Services Engineer at Onshape. Dan has been part of the Onshape team since early 2020 after coming over from Dassault Systèmes. In his previous role, Dan worked as an aerodynamic CFD consultant for automotive and heavy truck customers. At Onshape, he has used his industry and product expertise to help many new customers navigate through the onboarding process. Take it away, Dan.
Thank you, Serena, and thank you everyone for attending today and also for filling out the poll question. I really appreciate that. That will help us to, really tailor this discussion and presentation around what the audience uses today. So as Serena mentioned, my name is Daniel Kane. I'm on the Technical Services Engineering team here at Onshape and PTC. So I'm currently working in a pre-sales capacity where I'm working with a lot of companies and prospective customers who are considering making the switch to a cloud-based CAD and PDM solution. And that's kind of the focus of what our talk is going to be about today, about some of the issues that design companies and teams are currently facing, particularly around all of the data that is created throughout the design process, right? The managing of all the files and different data types that are created as you're going through the design process. And we'll look at a few of the existing solutions that are out there today and compare and contrast different approaches to solving these fundamental data management problems. So how I want to start off is going through some of the high-level issues that we see prevalent in the industry today that engineering teams and companies are facing, right? Again, sort of revolving around data, communication, and really just, these aren't necessarily new problems. A lot of these have been around throughout the design process for a long time, right? Even before the introduction of computer-aided design, back to the sort of drawing board days, right? When you would put a drawing in and out of a physical file cabinet. That was sort of the original check-in, check-out process. I think this will do a good job to sort of set the stage here and define some of the high-level issues that we see teams facing. So the first one I want to address is the ability to provide sufficient access to design data, not just for engineers and designers, but also all the other stakeholders in the process, right? So it's not just the designers who are going to need to see all of the files, right? It may be upper management, it may be manufacturing or different, teams within the company. An issue that a lot of teams face is how do we provision access? How do we give access to the right files? And how do we give the right access to the right people? Not just, here's a file, but is it view only? Can you actually make edits to that file? And sort of having a system to allocate those permissions effectively is a challenge that we see engineering teams facing. With regard to design changes, right? Your first design in the design process is never going to be your last. And there's going to be a lot of iterations along the way, whether you call it versions or revision or however you manage it internally, you have to have some process in place. And ideally it would be, robust. It wouldn't really get in the way of the actual design process, but you need to have a sort of an audit trail and a good way of managing these different revisions along the way. The other one is communication with remote teams. In today's age, I'm coming to you live from my bedroom, right? But even before the pandemic, engineering teams and companies and supply chains are becoming more and more global. And you need to be able to communicate across time zones and across different geographic regions. And this communication with regard to design is often very specific, right? You have to give some sort of design feedback or portray ideas. And it can be difficult with these dispersed teams. And then along the lines of communication is also including external stakeholders. So it's not just people within your company who may need to see your design data to get their eyes or hands on it. It may well be also people outside of your company, prospective customers, maybe contractors or suppliers need to be able to participate within the design process so they can give some sort of upstream feedback, right? Late stage design changes is what we're really trying to avoid in the design process. So getting people involved early on is very valuable from a business perspective. But when you're communicating with external stakeholders, it can be difficult to have sort of secure communication, right? Controlling your own IP while still getting other people's eyes and hands on the data. And so I don't think this is necessarily a comprehensive list, but I think it casts a good net for the discussions and the topics that we're going to go over in today's presentation. So, these issues, like I said, have been around for a while, and there are solutions that exist today to help address these problems. A very common and popular one is PDM, Product Data Management. So this is essentially, a software, a program that was developed to address some of these fundamental issues that come up throughout the design process, right? The enormous amount of CAD data that is created, the multiple versions of different files, of part files, of assemblies, where are the references going? Which revision is this? PDM provides a way to sort of help manage this, help keep it concise and clear. And what it is sort of at its core is essentially an index database of CAD data to allow you an effective way to query it, an effective way to manage it and store it in a searchable, clear and concise way. And I think what's going to be valuable here is to take a little bit of a step back, right? And to not necessarily dig in deep to the architecture and sort of the nitty gritty of how exactly does PDM work, but instead to think of it at a high level, at sort of a business level, think about what purposes does PDM fundamentally serve? If I'm someone, a manager or a decision maker who's considering purchasing and implementing PDM at my company, what am I expecting it to do? The first one here, and what I've done is I've laid out 5 items. And again, I don't necessarily think it's comprehensive, but I think these are sort of the 5 major ones that we expect PDM to help with. The first one is allowing companies to set up backup processes. So it's not necessarily going to come out of the box, with PDM. You're not necessarily going to have backup processes in place day one, but it gives you a system and sort of a tool to set up these backup processes, right? We always want to be going forward, never backwards. So what we really want to prevent is any sort of data loss through corruption or other means. We want to be able to back this up to give us a bit of peace of mind. And PDM allows you a way to do that. The next one here is managing versions and revisions. So I mentioned previously, your first design is very rarely going to be your final design. And you need a way to manage the versions and revisions in between, whether it be a formal release process, right, where someone actually signs off on it, or some sort of formalized methodology internally to help manage, track, and have a clear view of these versions and revisions. The next one has to do with collaboration, right? You want, in a file-based world, you need to prevent multiple users from accessing and editing the same file at the same time, right? This may well lead to conflicting changes that the two engineers are making simultaneously, and also confusion, right? If we're both making edits, whose edits are right, whose edits are final. And so what PDM allows you a way to do is establish a check-in and check-out process, where when one engineer checks out a file, right, a design, they can make their edits and no one else can access the design until they check it back in. And so this gives you a way to prevent this sort of overwrite, to prevent conflicting changes. Next one has to do with a central location, right? So you need sort of a centralized, particularly with these dispersed teams, right? Global teams. Where do I go when I'm looking for a specific file? You want to have a centralized location where you know if I need the latest version, I'm going to look in here, right? So it's sort of a single source of truth. And PDM does that with this sort of indexed database, right? All of my data is within this database, and I know if I need to find something, that's where I'm going to go. The final one here is searchability, right? So you need to be able to not only know where to look, but also have the ability to quickly find things. And so this indexed database that is PDM allows you a very effective way to, set different metadata fields and search based on different parameters, whether it be part name, part number, or other sort of metadata properties of that part. PDM allows a solution to quickly search and find the data that you're looking for. And, I mentioned that what we're going to do here today is compare and contrast some different approaches to solving these data management issues. I think the fundamental contrast that we're going to draw is between file-based, install-based PDM implementations versus a cloud-based approach. And so when we lay out these purposes that we're expecting PDM to solve for us, there's a bit of a paradigm shift when we go to the cloud. And what I've done here is sort of eliminate a few of these purposes that are no longer relevant or no longer necessary. So when you talk about backup processes, when you use a cloud-based implementation such as Onshape, all of your data is being automatically and redundantly backed up on the cloud. So you have guaranteed data retention, and you no longer have to worry about backing up your data because all of these processes and systems are in place automatically in the cloud servers in the cloud. When you talk about versions and revisions, this is still going to be, something that's relevant, right? Your design process is still going to involve different versions, different revisions along the way. But what we've done is sort of wrapped it all into one sort of cloud platform, right? So your design interface is not necessarily separate from your data management interface. And we'll look at this in Onshape just a little bit later, but that's still going to be relevant and is actually still, solved in this cloud implementation. The next one's really important though. When we talk about collaboration, the reason that check-in and check-out processes exist is to eliminate the problem that comes from a file-based world, where when you have multiple users editing the same file at the same time, they don't see each other's changes, and we have to find a way to lock other people out while someone is editing. But if you think about working on a group project in a Google Doc environment, I don't have to, save a copy and send it to someone else or worry that I'm in the same doc with someone at the same time. I can coexist with my coworkers in the same doc simultaneously, and I can actually see their changes in real time. And what's been done with these cloud implementations is that same idea applied to 3D mechanical CAD, where you can have multiple users in the same design at the same time. And what they can do is they can see the other engineers' changes in real time when they make it. So there's actually no need to have a check-in, check-out process anymore because updates are reflected in real time across the world. And again, we'll go into the platform in just a little bit to sort of see what that looks like. Central location, right? So cloud-based is inherently centralized, where anyone who has access to the internet can access the cloud environment. So no matter where you are, you know that we have this central place to go on the cloud. And searchability is going to look pretty similar, right? You can apply different fields, different metadata fields to your designs, to your data, and you can search it in a very similar way that would be possible in a PDM implementation, in an install-based PDM implementation. And so what I want to do is, what I've laid out here is sort of 5 main problems or pain points that we see companies facing when interfacing with PDM. And what we're going to do is sort of compare and contrast how these issues are sort of attacked in an install-based implementation versus a cloud-based implementation. And we'll sort of go through these one by one and compare the 2 scenarios. So the first one here has to do with the hardware and infrastructure required to run the PDM. So in an install-based PDM implementation, there's hardware that's required to even get it up and running, right? You need to have servers that host all of your local data, and you need to have powerful processors that are constantly backing up all of the new data created. This is just kind of right off the bat. In order to get up and running, there's a barrier to entry in the need to install this hardware. And then once you do install it, maintain and upkeep all of this hardware throughout time as you're dealing with annual or quarterly service packs, right? So to update your CAD program, you also have to update your PDM. You have to deal with that on a frequent basis. And then if you have multiple offices at multiple locations, you have to sort of deal with the syncing of the data across these multiple locations. So really, there's just a lot that goes into it from a hardware IT perspective that not only has sort of a cost associated with it, but also requires time and some sort of expertise in order to manage and upkeep this and keep it running smoothly. And I guess to sort of summarize it, is this all kind of falls on you as a company, right? This is all on you to make it happen and make it work. And when we think about instead sort of a cloud-based approach, as is the case with a lot of software as a service businesses, right? SaaS businesses, this is all kind of handled for you, right? So in a cloud-based implementation, all of your data is stored on the cloud. All of the processing power that goes into running and upkeeping even your CAD program is all handled remotely for you in this cloud-based implementation. So there's no hardware required in order to run a cloud-based application like Onshape. So what I'm going to do is I'm actually going to leave my presentation here and jump over to Onshape to kind of see, what this looks like in practice, right? Great in theory. How does this look in practice? So what I've done here is I've pulled up, my web browser, right? So I'm operating Google Chrome here, and I'm going to use my web browser to access my design environment. So there's no installed applications that I have to boot up. Anything that can run a web browser can run Onshape. So I'm going to simply come to my website, enter my credentials, and sign in. Again, no downloads, no installs, no dealing with license keys at all. Can really access my design environment as well as all of my company's data simply by signing in on the cloud. So you'll see I have access to all of the company folders that I've been shared into, maybe some projects, and also some recently accessed designs to quickly pick up where I left off. I'm able to utilize my web browser to easily open multiple designs in parallel using the tabs. right? So I can quickly open multiple ones, fly around. And what I can do is I can actually open, in this case, a top level, fully featured vTwin engine design is built natively within Onshape. You could see it, it did take a couple seconds to load up, but no more than 5 or so. And this is fully featured CAD, right? And what I'm operating on is my laptop, right? My 2019 MacBook Pro, good machine, but it's a Windows, it's not a Windows device, right? It couldn't run a lot of the install based applications. And like I said, I'm working from my bedroom, right? No sort of crazy infrastructure in place. I just have my laptop and I'm able to open up this type of top level assembly, go so far as to animate it. And what I'm going to do here is really utilize, more processing power than I would ever have locally. Right. I think that's kind of the takeaway from a hardware and infrastructure standpoint is you're not limited by what you have in your local machine. Right. My local laptop could not support the animation or opening of this engine, but because we're cloud based and leaning on Amazon Web Services, we're able to get more computing power than we have locally and be able to run this kind of top level CAD without a top level machine. So, from a hardware and infrastructure perspective, on day one, you can be up and running in a cloud-based implementation without the need to install or upkeep any sort of local hardware. So the next slide and the next sort of thing I wanted to talk about here has to do with collaboration. So we touched on this earlier, right? With install-based PDM, you're going to have a sort of check in and check out workflow. And what this does is in the file-based world, prevent conflicts, prevent confusion, and which in terms of which file is relevant, which file is real. And this check-in, check-out system is good, right? It does prevent that. It locks people out. It provides organization, right? And sort of established workflows to allow teams to work together. But fundamentally, this is going to be a serial workflow, right? Where when someone has it checked out, I can't access and make my changes, right? I'm going to have to wait until that other engineer checks it back in, and then I can go in. And so, it's sort of one after the other with this check-in, check-out process. And of course, that's when people play by the rules, right? There's always situations where someone forgets they have something checked out, maybe goes home for the weekend, and then you have an issue where no one can access this design. And so, again, this is sort of fundamental to a file-based world, right? This has to do with managing the files and managing the versions and copies of these files. When we talk about, a cloud-based approach to this, again, it's sort of like the Google Docs style of collaboration. You can have multiple users in the same design at the same time collaborating together. There's integrated comments to be able to communicate among these engineers and have very targeted and specific communication. And what it allows you is a single source of truth on the cloud. Because you see these updates in real time, there are no questions about what is the latest version, right? What is the most up to date? As soon as anyone makes their change, you can see that change in real time. It's a centralized database on the cloud. And of course, you will never get locked out of your designs. So again, let's pop back over to Onshape and see how this works in practice. So I've jumped back over to my design environment, and I'm going to open up this log grapple design. And so I am Dan, the manager of this CAD design team. And so what I want to do is delegate some tasks to my team members. members, right? I want to get other people involved in the process. So what I'm going to do is actually identify an area of this design that seems to be lacking, right? This doesn't look right. It seems like there's a part missing. So what I'm going to do is outsource this task to someone else on my team. So I'm going to share them in and give them permission to access this design. Again, no copies, no files. I can simply allocate permissions to the data where it lives on the cloud. So you can see I already have my manufacturing team in here, my engineering team. But this task I think is well suited for Debbie, the designer. And so I'm going to go ahead and share her in to this design instantaneously. So how this looks from her end, even if she's not within Onshape, get an email telling you that you've been shared into a document. Directly from that email, you can jump right into this same design with me at the same time. So again, no searching through files, trying to find exactly the right version. You get brought directly into this design simultaneously with Dan, the manager over here, right? So you can see these social cues that tell you someone else is in your document with you, and you're actually coexisting in this same environment together. You can communicate back and forth by using this commenting tool. So you can actually at the other person, tag them. And you can give some direction. Seems like there's a missing plate here. If only I could type. And what you can do is actually give some context to this, right? This is pretty ambiguous off the bat. What I can do is choose to tag an entity. So I'm going to zoom in on this little pink thing sticking out here. Go ahead and actually add the edge of it to my comment. And then I can assign it as a task as well. Those built-in task tracking within Onshape. So again, all these sort of company functionalities, your data management, your actual design environment, your task management can all be rolled into this one company environment. So I can go ahead and actually assign that as a task. And now it pops up automatically on her side, right? And from this tag, it'll zoom, pan, rotate you to the same view. So you know exactly what is being asked of you, right? There's no ambiguity in this comment. So I can say, you know what, Dan, I'm on it. And go ahead and reply. Again, that will sort of be seen in real time here. And so I'm able to communicate back and forth, delegate tasks, and coexist, like I said, in this environment here simultaneously. But as I'm navigating here on the left, if I want to go ahead and maybe clean this up a little bit so I can really focus on the area of the design that I've been tasked with, if I go around and I hide these different parts here, I see those same parts hidden on the right side, right? So any change you make to your design, whether it be changing a part, adding new parts, hiding or showing something, it all gets reflected across the board in real time. So we're able to come in here and effectively collaborate without having to check in or check out any of these designs. So coming back over to my slides here, the next point I wanted to discuss has to do with dispersed systems, right? So PDM was designed as a program to be put on top of existing CAD systems to help deal with the data and the files that are created by these install CAD applications, right? So it's a separate system that was almost put on as honestly a bit of a Band-Aid to a more fundamental issue that is the file-based nature. But because these are dispersed in separate systems, you end up with separate hardware, as we talked about. You have to sort of upgrade your service packs and for both separately. And if you have multi-location companies, I think we talked about this as well. There's actually additional software required to be able to communicate and interface between the PDM instances at each of these multiple locations. And so what you're able to do with a cloud-based approach here is sort of roll everything into one, right? You can exist in more of a unified platform environment for the entire company, and not just, one environment for CAD, one for data management, everything rolled into one, right? So you get instant deployment because this is a company environment. I'll show in a second. It's very, very easy and simple to deploy additional users, right? To get more people up and running. There's no additional hardware. I mean, in fact, none of this in this cloud-based approach requires additional hardware. And the data management is built right into the design process. And this is an important one, and I'll show this in real time as well, is the ability to deal with the revisions and the dealing with the actual data management in the same interface, in the same environment on this unified platform. The other thing I'll mention here is the fact that there's automatic updates. You'll never have to deal with installing the newest update. It happens automatically, in Onshape's case, every 3 weeks in the background, right? So it's not something that you, as the head of the IT department, have to deal with. It happens for you. But let's jump back over. Let's go back over to Dan, the manager here. And as the manager, of this company, I have full visibility and edit privileges to my company settings. So this is where you're going to manage your user base, right? All the users in your company. Again, you can add new users very easily. Just enter their email. You can organize your company into teams. You can define things like custom properties or different categories or permission schemes. But the one I want to focus on here is the built-in release management. So again, we say instant deployment on day one. All you need to do to turn on these release management workflows is simply tick a box, right? So I can tick this box, and now the engineers or designers in my company can start submitting their data, right? Their design data for approval. And it's not just design data. We actually haven't even gotten in to a lot of the flexibility of Onshape. You can upload and store really any type of file, not just CAD data, into Onshape and actually submit it for approval as well. So again, this is built right in. This sort of company level data management functionality all exists in one interface here on the cloud. There's a lot of really granular permissions you can get into from a release standpoint. Unfortunately, we don't have time to dig too deep into here. But I think what would be useful is to go through and kind of see what this looks like in practice, right? So I'm going to go back and I'm going to pull up Debbie's screen here. And what she's done is she's designed this missing part. Okay, this looks great. She's actually done it through managed in context design, where you can reference, the geometry of the assembly when you're building these missing parts. And it looks like she's created a drawing as well, right? So we've gone through this process where we've identified a missing part, designed it, and then created a technical drawing of it. You just update it real quick. And from this environment, you can directly submit this for release for approval, right? So I can right click on this drawing and choose to release it. It's going to prepare a release candidate for me. I'll see the part already has a part number assigned. Maybe my drawing needs one too. So I'm going to go ahead and actually sync these up, give them the same number. You put some information in here, some notes. This is the missing plate. You can dig into the properties as well, right? So I can see the properties of this part, dig into some of these things that need to be defined before actually releasing it. You go ahead and put Dan, the manager, as the approver. And now I can submit it for release. And now this is sort of off my plate, right? This is into the release process, and I can keep doing my other work. If I come back to Dan, the manager here, what's going to happen on his side is he's been tagged for a release. So what he can do is actually go in and see the release candidate. Oops, let me just go ahead and refresh this. There it is. So he'll get notified, right, telling him that he has a pending approval. You can view it, use again the tabs in your web browser to open up the drawing in the part, go in and review it, maybe give some sort of comment, feedback, and then actually go through. And maybe I should have looked at it first, and I'll take a quick glance. All right, part looks good. Drawing looks good. So what I'm going to do is go back over here and actually release it. And so now this has gone through the formal release process. That part in drawing will have a different sort of tag in the database, and those are now released parts at Rev A. So again, this is all unified, right? I never left my modeling environment. I'm able to submit things for release, review them, sign off, and now I can even go into my versions in history, which we haven't really gotten into too much, and see that Rev A has been approved. So again, no sort of dispersed systems idea here. We're able to do all of this from a unified company platform. The next one here has to do with accessibility and security. So this is one of the first issues that we touched on, in those early slides, right? The ability to give access to all people who need to be able to see and view this design. So with traditional install-based PDM, there's sort of some inherent trade-offs between security and accessibility, right? Depending on how you want to implement it, if it's strictly on-prem versus, maybe building a web application that interfaces with that on-premise server, you either need to be able to VPN in to be able to access the on-prem, or if you have a web app, you're sort of charged with the security aspect of it, right? You need to go in and define this security in this web application to ward off any sort of web attack or anything like that. So there's sort of some inherent trade-offs, and that's just from sort of outside people, wrongdoers. The other side of this, though, has to do with the file-based nature, right? So when someone checks a file out of a PDM vault, there isn't really control or visibility of what happens to that file. You do not know if it's being forwarded on, if there's copies being made. You really sort of lose track of that file once it leaves the vault. And this makes it difficult to then securely involve third parties. If you send them a file, who's to say what they're going to do with it? So when you then transition back to sort of a cloud-based approach here, the accessibility is inherent in the web-based nature, right? We saw that. Anyone who has a web browser can sign in and be able to access this data. But the web security is handled at a much bigger scale, right? When you outsource to a company like Amazon or Google, they have the economies of scale to be able to set up a very robust security infrastructure so that you can now have this wide-ranging accessibility on the cloud while being guaranteed of your data's security. When you talk about, corresponding with external parties, you can also set granular permissions where you can share someone in, but prevent them from copying or exporting that data. You get very granular with it. And from an analytics standpoint, sorry, my last bullet point here, you can actually view things like, where has my data been accessed? How many exports have existed in my company? You can go in and have this visibility that you've never had before to be able to be very guaranteed of your data's security. So I'm going to very quickly now pop back over and go into some of the sharing permissions. So what I'm able to do here is very granularly control what permissions I'm allocating, whether it be edit or view only, whether they can copy or export this design. Again, very granular control when you're sharing out your data. And you can do this with people outside your company as well. They can create Onshape accounts and you can share them in so that just through a web browser, they can actually access these designs. The other thing to briefly show is this analytics. What I can do is get sort of a 30-day summary, of my company and understand everything that's going on, right? You get a ton of visibility to where your data is being accessed. I was recently down in Florida, as you can see, and you can understand where engineering time is going, where the exports have occurred. So a ton of visibility here into your company, and a lot of peace of mind surrounding security. All right, the last point here to cover is the complexity, right? So with install-based PDM and CAD applications, again, it's sort of a way to manage the enormous amount of files and data that get created. And you end up with your engineers and designers interfacing with it at a pretty consistent basis, right? Anytime they need to access a file, they need to check it out. They need to interface with this PDM client, and they sort of end up becoming data management experts, and their focus isn't necessarily on the design process anymore. And that's a big thing of what we're trying to do with this cloud-based implementation, is allow designers and engineers to focus on the designs, right? You're not focused on data management. That's just sort of built in, and you can now put your attention back where it should be, onto making innovative, creative, awesome ideas. It's a very flexible system that allows a lot of, a lack of fear when you're designing, because you have things like infinite rollback capabilities. Now, again, there's a lot we haven't gotten into here today with regard to the different approaches to design. We've implemented sort of a GitHub approach to branching and merging, and applied it to 3D mechanical CAD. But again, it just sort of allows you to go back to the basics, focus on design, and let data management get out of the way of the design process. So that was all I was hoping to go through today. I hope that was helpful and informative, and hopefully I can answer any questions that come up throughout the presentation.
Well, thank you, Dan. I think everyone will agree that was definitely informative. And now we will move forward into the Q&A session, so you can get to those questions. And we've had some coming in already. And for all our attendees, if you have something you'd like to ask, please submit your questions using the Q&A tab in the Big Marker chat panel. And if you don't see that panel, click the blue chat button that you see at the bottom of your window, and that'll pop it right up for you. And if we don't get to your question the time we have today, don't worry, we will follow up with all questions submitted. So the first question we have for you is, how is the original design saved before changes are made?
Yes, great question. Let me go back and share my screen again. So the way it works is, because you have this very flexible system where multiple people can be making edits simultaneously, you need to have a very robust, revision control in place. And the way we handled that in a cloud-based implementation is by tracking every change that's made to the design, right? So what I'm able to do is go back and look at all the changes that I made. So simple things like hiding or showing something, moving things around, updating views in my drawings, all gets recorded in here automatically. So what happens is you have the ability to then go back to any previous point in time, right click and either view it or actually restore back to the way the design looked at that previous point. So I think there was a bullet on that last side saying infinite rollback capabilities. Every change that was made to this design dating back to when it was created is automatically stored in here. There's ways to highlight, specific points in time that you deem as critical using what are called versions here. So I can create a version to have it stand out in my design process. But every little change is tracked as well, and you always have the ability to bounce back to that previous point in time.
And you demonstrated for us earlier how multiple people can work in the same file at the same time and be collaborative. You compared it to a Google Docs kind of experience in that sense. But what happens if two people try to change the same thing at the same moment?
Sure. This is definitely something I receive a decent amount. Let's see if we can demonstrate it. So I'm going to pull this up live, right? I'm going to remove this context. And so let's say Dan on the right wants to chamfer this edge. Meanwhile, Debbie thinks, you know what, that's actually better suited to a fillet. What's going to happen is that these changes do not get recorded until you hit this green check mark, right? So it's really a who does it first. But you also get these social cues that tell you someone else is actually working in here. So maybe be careful. But if I chamfer this, and confirm that, then this doesn't know, it'll sort of error out, right? I can go back and see that, my fillet doesn't know what edge I wanted. Maybe I should reselect it. So, if you run into the situation where you're working on the same edge at the same time, there's ways to handle it. We find that most companies, it's more how this applies to sort of top level assemblies and how the lower things roll up to it, that this becomes really, really powerful.
That makes good sense. And we've seen a lot of the ways that being cloud-based is very advantageous. What happens, though, if someone loses internet access for some reason, there's some kind of outage?
Sure. Yeah. So great question. The way it works, so Onshape is strictly cloud-based, right? So there is not an offline mode of Onshape. And the reason for that is a lot of what we're seeing here with this change tracking, right? In order to be able to have this single source of truth, you need to be operating in the cloud on the web. One thing I'll say is there's not really significant internet requirements to run Onshape. So you can, boot up a mobile hotspot on your phone maybe, and be able to run it pretty smoothly through that. And you also, of course, have the ability to export your designs to have them locally.
And someone would like to know about what file types they can use with Onshape.
Sure. So I think one of the first things when Onshape was created that a lot of development investment went into was a translator, right? Because it's new to the scene. And the companies we interface with are almost always coming over from some other CAD platform. So from an import perspective, pretty much any standard file type can be imported, from a 3D perspective in parts and assemblies, drawings as well. You can import 2D models to then design off of. I can maybe, so there is documentation online of, supported file types. From an export perspective, I can maybe show it here real quick. You also have a wide variety of choices, again, depending what you're exporting. If you're working with a drawing, obviously your selections are going to be different than when you're working with a 3D model. But we have a wide variety of file formats that we can export in, STLs for 3D printing or really whatever you need. There's also a lot of flexibility in sort of how you export, right? So you can locally download it, or you can actually email a file download link to someone directly from this environment. So you can add email recipients and set security measures. There's no worry about attachment limitations because you're just sending a link from which they can download the data.
And I think you touched on this a little bit earlier in terms of assigning tasks to people in your collaborative work. But can you expound on the task management capabilities, what options people have when working in Onshape?
Sure.
For assigning things to particular engineers?
Yes, of course. So there's a few different ways to do it. I think I demonstrated one of them, right? The idea of assigning a task via a comment. As the person who's been assigned the task here on the left, as soon as I finish it, I can then, right from this environment, resolve it, and it's no longer an outstanding task for me. And there's a few different ways you can sort of use this. So releases automatically trigger a task. And what you can do is go to your action items page and have a bit of a to-do list for yourself, right? So you can see, okay, this is submitted for my approval. I need to do this. There's been some other tasks in the past that have been assigned to me, and maybe these are, a bit outdated. Maybe I should actually check up on those. But you can also see not just open tasks, but also closed ones, right? So you can go back through your history and see, hey, this is all the things I've done. These are all the tasks I've completed, and be able to use that to maybe show how productive you are. The other thing I'll say is, with regard to the release management settings, you can actually prevent releases if there's an outstanding task. So just to make sure that when we're doing this, we're being very robust about it.
Great. Well, thank you for showing us all of that. We made it through all of our questions. Excellent. But don't hesitate if anybody thinks of anything after the fact to follow up with us via email. We're happy to answer all of your questions. And you will get an email notifying you when the recording of this webinar is ready. I'd like to thank our sponsors, Onshape and PTC, and all of our attendees today. We appreciate your time and your interest. We hope you found this information useful. Have a good day, everyone.
Thank you, everyone.